Malicious code refers to viruses, worms, Trojan horses, logic bombs, and other, uninvited, software. Sometimes mistakenly associated only with personal computers, malicious code can attack other platforms. Actual costs attributed to the presence of malicious code have resulted primarily from system outages and staff time involved in repairing the systems. Nonetheless, these costs can be significant. Viruses and worms are related classes of malicious code. As a result, they are often confused. Both share the primary objective of replication. However, they are distinctly different with respect to the techniques they use and their host system requirements. This distinction is due to the disjoint sets of host systems they attack. Viruses have been almost exclusively restricted to personal computers, while worms have attacked only multi-user systems. A careful examination of the histories of viruses and worms can highlight the differences and similarities between these classes of malicious code. The characteristics shown by these histories can be used to explain the differences between the environments in which they are found. Viruses and worms have very different functional requirements. Currently, no class of systems simultaneously meets the needs of both. A review of the development of personal computers and multitasking workstations will show that the gap in functionality between these classes of systems is narrowing rapidly. In the future, a single system may meet all of the requirements necessary to support both worms and viruses. This implies that worms and viruses may begin to appear in new classes of systems. A knowledge of the histories of viruses and worms may make it possible to predict how malicious code will cause problems in the future. Some of the malicious software are: virus, a code segment that replicates by attaching copies of itself to existing executables. The new copy of the virus is executed when a user executes program. The virus may include an additional payload that triggers when specific conditions are met. For example, some viruses display a text string on a particular date. There are many types of viruses, including variants, overwriting, resident, stealth, and polymorphic. We also have Trojan Horse, a program that performs a desired task, but that also includes unexpected and undesirable functions. Consider as an example an editing program for a multi-user system. This program could be modified to randomly delete one of the user's files each time they perform a useful function, such as editing, but the deletions are unexpected and definitely undesired. Worm, a self-replicating program that is self-contained and does not require a program. The program creates a copy of itself and causes it to execute. No user intervention is required.